Hi students, hope all of you are doing well. So in the last class we discussed about the concept of deadlock. There we have seen what is deadlock, conditions that cause for deadlock, and also we discussed about how to represent resource allocation state. We have seen that there are two methods for representing resource allocation state. One is the graph model and the second one is matrix model. So in case of graph model, we discussed about two methods of representing resource allocation states. One is resource request allocation graph and the second one is wait for graph. So these are the two methods which belongs to the graph model. We have the second method, second category of representing resource allocation state to a process. That second method is referred to as matrix model. So this is one of the simplest way of representing resource allocation state to the different processes. So in this case, or in this model, we are going to use two matrices. Students, to represent resource allocation state, we use two matrices. One is referred to as allocated resources, and the second one is referred to as requested resources. We use totally two matrices. The first matrix, it represents information about allocated resources to the different processes, and the second matrix is going to represent the information about the resources which are requested by different processes. Suppose if we have n number of processes and r number of resource classes. In that case, these matrices, that is first and second matrices, they will be of size n into r. It indicates that the number of rows in the matrix will be depending on number of processes, and number of columns will depend on number of resources available. Number of resource classes that are available will decide number of columns, and number of processes that are considered for execution will decide the number of rows. Okay, students, here we have an example. Assume that you have a resource request allocation graph as shown in the diagram. Okay. Okay, in this case, if you just look at the diagram, we have processes Pi, Pj, and Pk. And we have two class of resources, printer and tape. We have one printer, which is indicated by one thick dot, and we have two tape resources, which is indicated by two dots in this particular tape resource. Okay, now let us see how to represent this entire information by using matrix model. So as we discussed, here we require two matrices. First one is allocated resources. So in this matrix, what we do is, first we just note down name of the resources. First we have printer, then we have tape. Then here we write name of the processes. We have three processes in the diagram, Pi, Pj, and Pk. Now this matrix indicates that the process Pi is allocated with 0 number of printers. Means no printers are allocated to the process Pi. However, Pi is allocated with one tape drive. The first row indicates that the process Pi, it is allocated with 0 printers and one tape drive. Similarly, the process Pj, it indicates that it is allocated with one printer and 0 tape drives. And similarly, process Pk, if you look at this example, it is allocated with 0 printers and one tape drive. So this is how we represent information about allocated resources to the different processes. This particular matrix, we call it as allocated resources matrix. Then we use second matrix, which indicates the request made by different processes. The second matrix gives information about the requested resources by different processes. Okay, if you look at this matrix, it indicates that the process PI, it is requesting for 1 pointer and 0 tape drive. Similarly, process PJ, it is requesting for 0 pointers and 1 tape drive. And for PK, we have 0, 0. That indicates that PK has not requested for pointer and tape. Like this, we use 2 set of matrices in the matrix model. Now, by looking at this complete diagram, we can write information about total resources and also free resources. Okay, students, if you look at this first information, total resources, we have 1 pointer. It can be observed from this diagram. Okay, we have 1 pointer and 2 tape drives. Same information we are representing in the form of a row matrix. Then similarly, we have represented information about free resources. Right now, we have 0 printers and 0 tape drives available. Of course, we have a total of 1 printer and 2 tape drives. But however, 1 printer, it is allocated to process PJ, and out of 2 tape drives, 1 tape drive is allocated to the process PI, and 1 tape drive, it is allocated to the process PK. That's why right now, if you consider, the free resources will be 0, 0. Students, this is how we use the matrix model to represent information about resource allocation states. Hope you are understanding this topic. Okay, in the next slide, we are going to discuss about deadlock handling approaches. Okay, we have seen what is deadlock and conditions that cause for occurring of the deadlock. But however, the question is, what should be done when the deadlock occurs? So to handle the deadlock, we have 3 approaches. So the different operating systems can use different approaches. So generally, we can have 3 approaches for handling the deadlocks. So the first one is we have deadlock detection and resolution. This is the first approach we have. So in this case, the operating system is going to analyze the resource state to check whether the deadlock exists or not. Here in the first approach, the operating system is going to check whether the deadlock exists or not. Okay, if it finds out that the deadlock is existing in the system, in such case, one of the process is terminated. Simply here the operating system is going to abort some of the process, and when a process is aborted or when the process is deleted, whatever the resources that are available from that process can be allocated to other processes so that the deadlock cannot exist or deadlock should not continue. This is the first approach we have. And we have the second approach, which is referred to as deadlock prevention. So in this case, the kernel uses the resource allocation policy in such a way that none of the 4 conditions should occur, or otherwise we can say that the 4 conditions, whatever we have listed out for occurrence of deadlock, should not occur simultaneously. This care is taken by the operating system to prevent deadlock. Students, in the second approach, the kernel will see that the resource allocation policy should ensure that all the 4 conditions which cause for deadlock should not occur simultaneously. So that care is taken by the operating system to prevent deadlock. So it makes deadlock impossible. Okay. Then we have the third approach, that is deadlock avoidance. So in this case, the operating system is going to check the allocation state to determine whether granting of any resource request will lead to the deadlock in the future or not. Here at the beginning itself, the operating system is going to check whether any resource allocation to the process will cause deadlock or not in the future. If that is the case, in case if there is chance of occurrence of the deadlock, such resource request will not be granted by the operating system. By doing that, the operating systems or kernel will avoid the deadlock. So this is how we can have approaches for handling deadlocks. Remember, students, there are three approaches. The first approach is deadlock detection and resolution. So in this case, simply the operating system is going to find whether deadlock has occurred or not. If it is found that there exists a deadlock, in that case, one of the processes is terminated and all the resources that were allocated for that process will be allocated to other resources to see that that deadlock situation will stop or that deadlock situation should not continue. The second approach is deadlock prevention. In this case, the operating system will see that the resource allocation policy itself should manage that the four conditions which are required for occurrence of deadlock should not occur simultaneously. By doing so, the operating systems will make the deadlock impossible. The next approach we have, students, that is deadlock avoidance. So in this case, while allocating the resource to each of the process, the operating system is going to check whether allocation of any resource to any of the process leads to deadlock or not. In future, if any of the resource request allocation will lead to the deadlock situation, the operating system simply will not grant that particular resource. By doing so, the operating systems will avoid the deadlocks. So this is how the deadlock will be handled by different operating systems.